Welcome back. This is Emmett, and in today's video we will be tackling this problem. So the equation y equals e to the point 5x and the point 210 are in the xy plane. So we want to find the minimum distance between the point and the curve. So I'm just going to draw this out here. I'm going to draw the point and curve. So the curve looks something like this, and I'm just going to label the point here 2, 10. Alright, and we want to find the minimum distance between this point and curve. So we don't exactly know where this point lies, but it lies somewhere along this curve. And so I'm going to take this point, right? I'm going to draw a point here, and I'm just going to call it x, y to represent a variable point, because we don't know what the point is that will give the minimum distance. And so I'm just going to leave it variable. And I know that the distance, we want to find the distance between this point and the curve. And so keep in mind, if this is x, and the equation is y equals e to the 0.5x, this y value is just going to be e to the 0.5x. So I'm going to write x, comma, e to the 1/2 x, right? Okay, so we have this variable point. And now what we can do is I'm going to use the distance formula from this point, which is variable. It changes depending on the x value put in, and this point. Okay, so recall the distance formula, use 2 points. I'm going to have this be x2, y2, and I'm going to have this be x1, y1, right? So x2, which is x minus x1, which is 2, and so this is squared, plus, and then y2 is going to be e to the 1/2 x minus y1 is 10, and this is going to be squared, right? And so now we have this distance equation, and this is an equation because basically x is variable, and so this changes, right? And so you plug in an x value, some x value along here, and you're going to get a distance. So I'm going to write y equals, and then we have this equation right here, right? And so if we can find the minimum value of this equation, well, then we can find the minimum distance. All right, so I'm just going to draw down below here. I'm going to draw this equation, and again, feel free to use your graphing calculator. But this equation looks something like this, okay? And so you can either use the minimum function on your calculator or find the derivative of this equation here and then find where it equals 0 and is a minimum. But however you do it, you should find that the minimum of this function here, which is represented here, the minimum is x at x equals 4.497, and the y value is 2.552. Okay, so what this means is at x equals 4.497, so you plug this into here and here, right? You get 2.552, and this is the minimum y value, which is also the minimum distance. So if we come back to what we originally started with, if we come back to what we originally started with, if we go to 4.497, which is, say, here, this distance here is going to be 2.552, and this is going to be the minimum distance. Alright, so this problem is not crazy hard, but it is useful for some of our other more challenging problems on our channel. With that, I hope you learned something and have a nice day.